this section, we will discuss about the traffic signal design. So basically, at the intersections where there are large number of crossing and right turn, so there is a possibility of several accidents, as there cannot be some orderly movement on the crossroad with two-lane, two-way traffic. There are 16 crossing conflict. So basically, because of that conflicting point, the problem at the intersection is more severe, and because of that, the traffic volume increases. So, in such cases, the traffic signal is recommended because the traffic signals are the automatic traffic control devices which could alternately direct the traffic to stop and proceed at the intersections using the red, green light signals as per the predetermined time setting. So here you can see that in Indian practice we follow generally the red, green and E for amber, or that is the yellow color. So the main requirement, or why do we provide signal? So the major requirement is to provide orderly movement of traffic. So for that, we have to draw the attention of the road users because it enables them to understand the meaning of light signals. Different light has their different significances. And that situation arises where to increase the traffic handling capacity also at certain situations, the signals are provided. Even signal can reduce the frequency of certain type of accidents that I have told that have caused due to the 16 crossing conflict point. Even signals can replace traffic police also. So because of that signal and the color code we have to have to follow the road users because here you can see in the diagram we have to provide sufficient time to respond and we have to also ensure the minimum waste of time because it is not only the vehicles that is moving, it is the pedestrians can cross the road safely at the signalized intersection. So when the signal system is properly coordinated, there is a reasonable speed along the major road traffic. And because of that, the automatic traffic signal may work out to be more economical when compared to the manual control. So basically, when the amber time is between the termination of green and the start of red, it is the clearance amber. Similarly, when the amber is between the termination of red and the start of green, it is the initial amber. So, a signal phase that is a part of cycle length allocated to traffic movement, it receives the right of way. Right of way, you all know that the way on which the vehicles move, that path that is allocated. So basically, what is happening here? The green signal time is allocated. After that, there is a amber time that is for 2 to 3 seconds. Then there is a red time that is allocated. So whenever one signal is green, then the other another signal is consecutively red, and in that red it includes the amber time also. So after the end of amber time, in one phase, it is the red time that is started. But on the another signal, there is a delay in the allocation of green time. So that is called as the all red time. That is also a part of that delay. So as I have explained the advantages of traffic signals, so there are certain disadvantages also, like the rear end collision may increases, even the improper design and location of the signals, it may lead to the violations of the control system, even the failure of the signal due to electric power failure or any other defect. It also causes confusion to the road users. But still, there are modifications going on the process of traffic signal. So, what are the different types of traffic signal? So, before moving on to the going on to the traffic different signal types, so the major is we can say that is the traffic control signals are there. One is the pedestrian signals are there, and some are special type of signals. So basically, here you can see there are the terms called fixed time signal. So for the fixed time signal, as it is pre-timed, basically the fixed time signals are the pre-timed signal and they are set to repeat regularly of a cycle of red, amber, green. So the fixed time signals are the repetitive signal times. So the timing of each phase of cycle is predetermined based on the different traffic studies. And it is the simplest type of the signal. And next comes the manually operated signal. So manually operated signal here is where the traffic police watches the traffic demand and varies timing of the phase and cycle accordingly. Then related to that, that is the automatic signal where the signal time based on the calculation it varies, and as the signal time is varies, the timing of phase and the cycle changing according to traffic demand. So in fully actuated traffic signal, the detectors and computer they are assigned for the various movement, and on that basis of the demand and the predetermined programming all are being calculated. So while calculating these factors, the signal design, so there are certain terminologies that will come. So that is an important part of there. The first is the in the definition part, various terms are used in the traffic signal. So the first is the cycle or the signal cycle means the period of time required for one complete sequence of signal indications. So basically, the part of the signal cycle time that is allocated to stop the traffic or to allow traffic movement is called the signal phase. So means the cycle starts from green, then amber, then red. So that complete cyclic process for one cycle or the time frame that is called as the signal cycle. Then comes the phase. So that is a part of the cycle that is allocated to one or a combination of movement. Suppose we have allocated for north-south direction one phase, then east-west direction one phase, then which is moving on the straight path and left turning another phase. So different phase you have to allocate. And after the phase, there is say the based on the phase, the duration of stop phase, the red phase, and the go phase or the green phase is there. So any of the division of the signal cycle during which the signal indications do not change is called the interval. Then these all things like the green interval time, that is the amount of time for which the movement receives green indication. Yellow time means the amount of time to which the movement receives yellow indication. Red means amount of time for which the movement receives the red time. So based on the different rate, and one more important thing that is left, that is the lost time. So basically lost time here, it indicates the time during which the intersection is not effectively utilized for any movement. For example, when a signal for an approach turns from red to green, what will happen? The driver of the vehicle, which is in the front of queue, will take some time to perceive the signal, that is the reaction time, and some time will be lost there before he moves. So this is known as the startup loss time, and based on these various terminologies, the calculation for the signal design is given. So as per the signal design methods, because there are mainly four methods: the trial cycle method, the approximate method, the Webster method, and design as per the IRC guidelines. So, based on the syllabus, the Webster method, most of the questions are coming from the Webster method. So, the first two methods that are approximate design procedure. Only Webster method of signal design is a rational approach with the objective to minimize the overall delay of all the vehicles entering the intersection. So in the Webster method, what is happening? It has been found from the various literature or studies that the average delay and the overall delay to the vehicle at a signalized intersection, it varies with the signal cycle length. So here one formulation is given in the Webster method of signal design, where it is mentioned that that is the C0. So based on the Webster method of traffic signal design, the as it is an analytical approach for determining the optimum cycle length, C0 the corresponding to the minimum total delay of the vehicles at the approach of the road intersections. So one have to calculate that C0 first, because C0 is the optimum cycle time. Whenever we will discuss the numericals, you can get an idea. Then comes the lost L, that is the lost time per cycle. So that is, for that one formula is there, NL plus R, or as most of the time it is considered as 2N plus R. So average loss per phase is 2 seconds, almost considered mostly. Another important phase in the formula is the calculation of YI, that is the major part of calculation. That includes the critical lane volume by the saturation flow. So what is here the saturation flow? So whenever these two terminologies come, basically the normal flow, that is the flow on an approach based on the design hour. So the normal flow value varies on the type of road. Say Q1 and Q2 for road 1 and road 2, you are calculated from the field study. So for the field study or in a traffic during peak hour of 15 minutes period, so the saturation flow of the vehicle is determined by that field studies by noting the number of vehicles in the stream during the green phase and the corresponding time. So in the absence of this data, the approximate value of saturation flow is estimated as 160 PCU per 0.3 meter width of the approach road. Or one formulation is there for that saturation flow, that is S equal to 525 W. So W is the width of the road. So based on this formulation, one numerical is there. So here you can see a fixed two-phase signal is to be provided at an intersection having four arms. So here you can see that is a four-phase signal intersection there. So this is the north, south, and based on that east and west. So what are the other parameters given? Eastbound road, where Q, that is the volume, that is the number of vehicles that are coming. So that is 400 vehicles per 900 vehicles per hour, and its width is 4. In that case, that is a northbound road where it is moving towards the north, the vehicles 800 vehicles per hour, and the width of the road is 3.6 meter. This direction is when the vehicle is moving on the south, that is 750 vehicles per hour. So width is 3.8, and here it is westbound, means all the vehicles are moving on the west direction. So it is 650 vehicles per hour, where the width is 4 meter. So different roads having different width and different number of vehicles which are crossing each other. So that is the simplest form of example that is there. Another thing is mentioned, time loss due to start delay is 2 seconds, and all time rate is 4 seconds. So width eastbound, west, north, south in the directions, different width are provided. Then calculation comes for the S, that is the saturation flow value. So for the saturation flow, it is 5 to 5 into W. So W is the width that is mentioned here. It is 4. Again 4. It is 3.6 and 3.8. So S calculation, you have to calculate S equal to 525 into 4. 525 into 4, 525 into 3.6, and 525 into 3.8. So these are the corresponding values. 2100. Here for again for 4, 2100. For 3.6 it is 1890. For 3.8 it is 1995. So that is the saturation flow. That is the calculated. Then comes after the saturation flow, that is the Q, or the total number of vehicles in that time, that is 900 vehicles per hour, 650 vehicles per hour, 800 vehicles per hour, and 750 vehicles per hour. For different directions, different vehicle counts are provided. Why? Why is the calculation for the critical parameter that is calculated? Because based on the normal flow and that ratio, that is Q and S. the ratio of y1 or y2 for every direction. Here it has four directions. So it is y1, y2, y3, y4. So for four different directions, it has been calculated. So while calculating y, that parameters, it is the formula comes as here 900 divided by the total saturation flow 2100. So the maximum here it is for 0.428, the value 650 by 2100, 0.309, 800 by 1890, and 750 by 1995. So in that east and west, so what will happen when you are giving a green signal to east? At that time, you can easily provide the green signal to west because this vehicle moves in this direction and this vehicle moves in that direction. So this is one phase. In that phase, you are opening the traffic for east and west because there is no way of collision there. This is moving in this and this is straight way moving there. On the next phase, you are opening for the way for north direction and south direction. Means you are blocking, giving red signal to east and west. So here the same way, east west are in one phase and north south are in another phase. So for this phase, when you are calculating the critical flow, it is 900 by 2100 and 650 by 210. Maximum value is 0.428 among these two. So you have to calculate, means consider the value of 0.428. Then comes the value of 0.423 and 0.375. Based on this calculation, 800 by 1890 and 750 by 1995. So 0.423 is the maximum value among these two. So for the critical flow, you are getting two different values. Then we have to use these two values how? Here, the summation of y, that is 0.428 plus 0.423, 0.851. So that is the critical. So then you have to calculate the lost time per cycle in the formula I have mentioned, NL plus R or 2L plus R. So basically 8 seconds for that calculation. So now the formula comes C0, that is the optimal cycle time. You have to calculate first 1.5 into L. So plus 5 divided by 1 minus that summation of the critical flow, that is 0.851. So when you input the values, so here basically L value you got there. So, and after getting that values, you are getting 114 second or say 115 second. In that 115 second, effective green time available is 107 second. How? This 115 second is allocated for the both the east-west one phase, north-south another phase. For two different phases, total time is 115 second. So what is given in the question? All red time is 4 seconds. Red time is given for each phase 4. So दो अलग-अलग phase के लिए it is 4 for one phase, 4 for another phase. So that means it is comes around 8 seconds. So 115 minus 8, 107. Now you have to distribute that 107 time to east-west direction one phase and north-south direction another phase. So for the north-south direction, based on that formulation, you are getting 54 seconds. For east-west direction, you are getting 53 seconds. So how it is coming? Here you can see this is the phase for north-south. Means whenever the vehicle is moving in the north-south direction for 54 seconds, it is green time. Then for 3 seconds it is amber time. And after that up to 115 seconds, it should be completely red. So now you have to also allocate the time for the another phase. So whenever it is green or amber, the whole phase will be in red up to 56 seconds. That is clear. Then for 4 seconds, it is the all red time. And after 4 seconds, you are allocating the another green phase time of 53 seconds plus here the another 2 to 3 seconds. That is the remaining time for the amber time. Then again the red will come and here another green will come. So in this way, based on the constant data, this calculation will continue. So what are the important parameters here? Stepwise, first you have to calculate the S value. From that S, based on the 5 to 5 W is the width of road, you have to calculate the Y, critical flow, based on the Q by S in that process. And you have to choose the maximum Y for the phase. Here we have chosen east-west and east and westbound in one phase. So that's why we are choosing any one from them. Another one we are choosing north and south in one phase. So then we are opting point 423. So based on these two summations, we are calculating the optimum cycle length. And after getting the optimum cycle length, we have to distribute that optimum cycle length for the east-west directions and the north-south direction traffic. So in this way, based on the Webster method, you are allocating the signal, because here the normal flow of the traffic on the approach road is it can be determined by conducting field studies. So based on the field study, these parameters are calculated. These values are only getting from the doing the test in the field. So after getting the field values, one can design this way. And there is also another software ism for conducting these studies. So this is the numerical for that. So you can go through it.